Howdy folks, Mr. Reed here, and welcome to One More Question. So, what I'm going to be taking a look at today is the idea of what would happen if we were to put some sort of base to a rational exponent, but not just one that's 1 over a denominator, but actually any rational number. That's a bit of a lie. I'm going to exclude negative rationals from this for the time being, because in this set of videos I haven't covered what a negative exponent will do yet. But if you are wishing to know what is going on, if you have some other rational, so something that can be represented as a fraction exponent, then this one's going to be at a medium level. You're in the right place. So let's get to it. All right, so generally, I really like writing things generally. So I am going to write down that this is c to the power of m over n. So the idea behind c to the power of m over n is that it could have some, and since I'm saying that these things have to be positive, what I'm really saying is that m and m are both, m and n are both whole numbers. So what we're going to do then is try to come up with an expression that allows us to understand what's going on here. So what we've learned so far is that if it was just an m and it's a whole number, that's the same thing as repeated multiplication that occurs m times. So I would have to keep on going until I had m of these c's multiplied together. The other thing, if you took a look at my last video, we learned that c to the power of 1 over n is the same thing as the the nth root of c. So the n that's in the denominator becomes the index on the radical that c is inside. That's pretty interesting too. There is one other exponent law that allows us to actually take a look at how this is written and break it up into parts instead. So m and n as a fraction could be rewritten, if we wanted to, as m times 1 over n. That would give you the same n over n expression. I'm going to regret picking m and n, even though it's pretty typical. I can't say them clearly. Or it would be the same thing as c to the 1 over n times m. Now, of course, those are the same thing. Just writing the two things that we're multiplying forwards and backwards. Fine. But I'm going to express this first one as being c to the m to the power of 1 over n. The reason I can do that, and I'm going to do the opposite on the other side here, so I'm going to put it inside of an inner bracket, is because there is this exponent law that says the following. If we have something like this raised to another exponent, then we could multiply those exponents together. Multiplying them together would be exactly what I have on this previous line. So we almost, when we're learning these, we usually go in one direction. So we usually start with something like this and then work our way back. But it's true in reverse as well. So what does c to the m mean? Well, if I backtrack to this line, c to the m is just the repeated multiplication there, which I kind of understand how that works. But it's also all inside of a 1 over n exponent, which if I look at what that means, well, the thing that used to be inside of that gets put inside of a radical. So I could put the c to the m inside of a radical, and that radical would have an index of n. Oh, that's kind of cool. So the combined exponent that we started with, the m over n, became this statement, which it's kind of a combined statement for the radical. So we still have c to the power of the m, which is the numerator, but we still have also a radical whose index is the denominator. And so we can actually always use kind of that sort of statement if we like. But it's also true that we could say it the other way around. It's also the case that if we had the nth root of just c, which is the inner part of that bracket, and then we took that and raised it all to the power of m, then that would also be an equivalent way to say that, which means that these two things are actually also still the same thing like they were up above. So the c to the power of m over n is the same thing as, whether you want it to be inside or outside, it doesn't matter, but there is an n index radical with either c to the m inside of it, or just a c inside of it, and you put the power of m on the very outside. The order is not important. As we saw, the left-hand side and the right-hand side are equivalent to start with on this line, and they're equivalent at the end too. So one way to say what we just discovered out loud is that if we're looking at this original statement up here, that you are going to take the yeah, that's right, the nth power of c and the nth root of c. I'm not good at this. All right, so the nth power of c and the nth root of c. Oh, I apologize. All right, so long story short, the order doesn't matter. So if you wanted to take the nth root first and then do the nth power, you would be okay. Good news is, we don't talk about it generally, usually when applying it. So the M and N, and even the C, those letters aren't important. What's important is that you recognize what's the base. In this case, I've written it down as a C. What's the numerator of the exponent? That's the M. That's going to become the power. And what is the denominator of the exponent? That's the N. That's going to become the root, and technically the nth root. So it tells you the index on that root. So hopefully you found that one helpful. It's just a general way of describing what's going to happen when you have any sort of positive rational exponent. If you want to see that actually being applied to evaluate some numbers, you're going to want to take a look at my next video. But if that's all you're looking for, hopefully that was helpful. As always, like, subscribe if you thought that it actually was of use to you. And take care, folks.